The thermal insulation design of the external building envelope in summer should not only consider the thermal effect of outdoor temperature and solar radiation, but also consider the natural heat dissipation effect of effective long-wave radiation on the external surface of the building. These three effects are integrated into a single indicator, which is called outdoor solar air temperature. The outdoor solar air temperature consists of three parts: outdoor temperature, solar radiation equivalent temperature, and effective long-wave radiation temperature on the outer surface. The long-wave radiation temperature is 3.5 degrees Celsius for the roof and 1.8 degrees Celsius for the external wall. These two figures are the solar air temperature variation curves of a day measured by a building in Guangzhou. The left finger is a case of flat roof, and the right finger is a case of flat roof and the east and west exterior wall. It can be seen from the left finger that the equivalent temperature of solar radiation is quite large. It can be seen from the right finger that although the temperature has the same influence on the roofs and the external walls in different directions, the influence of solar radiation is different, resulting in different outdoor solar air temperature in different directions. The flat roof is the largest, followed by the west wall. Therefore, in addition to the roof insulation to consider, but also pay attention to the west and east wall insulation. This figure reflects the solar radiation intensity of a place on the roof and the internal wall in a year. It can be seen that the solar radiation intensity of the horizontal plane in summer is the largest, and the solar radiation in winter is low, resulting in cold winter and hot summer, which is unfavorable throughout the year. Therefore, the horizontal area should be reduced as much as possible, and the main rooms and air conditioning rooms should not be arranged on the top floor. The south exterior wall is opposite to the horizontal surface. The solar radiation received in summer is small, and the solar radiation received in winter is large, which forms warm winter and cool summer, and is favorable throughout the year. Therefore, the southward area should be maximized, and the main rooms should be located southward. The east and west exterior wall is similar to the horizontal plane, and the solar radiation intensity is low. The influence of solar radiation is between the southward room and the top level room. The annual solar radiation on the north exterior wall has little difference, indicating that the room temperature is less affected by solar radiation and is suitable for room with constant temperature and humidity. The maximum solar air temperature is the sum of average solar air temperature and amplitude. The average outdoor temperature and average solar radiation intensity are substituted into the solar air temperature calculation formula to obtain the average solar air temperature. The solar air temperature amplitude is the corrected value of the sum of outdoor temperature amplitude and solar radiation equivalent temperature amplitude. This correction is due to the inconsistency between the current term of the maximum outdoor temperature and the maximum solar radiation intensity, so it cannot be simply added. The amplitude of solar radiation equivalent temperature is the difference between the maximum and the average equivalent temperature. Think about it. How to reduce the outdoor solar air temperature? Can we shorten the difference of outdoor solar air temperature in different directions by means of design? How to design to have better insulation effect? The thermal insulation design standard is to determine the degree of thermal insulation control of the enclosure structure, which is closely related to the regional climate characteristics, living habits, adaptability to climate, economic and technological level. The natural ventilation room mainly controls the internal surface temperature and requires a certain attenuation multiple and delay time to avoid overheating. According to the thermal design specification of civil buildings, the maximum temperature of the inner surface of the internal wall should be less than or equal to the maximum outdoor calculated temperature in summer for natural ventilation rooms. For the air-conditioned room, when the thermal inertial index is greater than or equal to 2.5, the heavy enclosure structure is required to be less than or equal to the indoor temperature plus 2 degrees, and when the light enclosure structure with D value less than 2.5 is required to be less than or equal to the indoor temperature plus 3 degrees. The requirements of the maximum temperature of the roof inner surface for the natural ventilation room are the same as those of the internal wall, and the requirements for the air conditioning room are increased by 0.5 degrees in the standard of the internal wall. Next, let's do an exercise. Find the attenuation multiple and delay time of indoor and outdoor temperature view to the inner surface of the western wall, the average temperature of the inner surface, the amplitude of temperature fluctuation, the maximum temperature, and the occurrence time. The average solar radiation intensity is known to be 206 Watt per square meter, with a maximum of 768 Watt per square meter at 16 o'clock. The average outdoor temperature is 30 degrees Celsius, and the highest value is 35 degrees Celsius at 15 o'clock. The indoor average temperature is equal to 0.5 degrees of outdoor average temperature. The indoor temperature amplitude is equal to the outdoor temperature amplitude minus 1.5 degrees. The indoor maximum temperature is 1 hour later than the outdoor maximum temperature. The west wall is 3 layers, inside on the left and outside on the right. Since the heat flow enters the indoor from outdoor, the level number is from left to right. One layer is internal plastron. Thermal conductivity is 0.81, and heat storage coefficient is 10.12. The two layers are rendered block masonry with thermal conductivity of 0.19 and thermal storage coefficient of 2.76. Three layers are external plastron. Thermal conductivity is 0.87, and thermal storage coefficient is 10.76. The absorption rate of solar radiation on the surface is 0.48. The inner surface heat transfer coefficient is 8.7, and the outer surface heat transfer coefficient is 19. The solution to this example is as follows. Firstly, the outdoor average solar air temperature and its amplitude are calculated, and then the average temperature of the inner surface is calculated. Secondly, the attenuation multiple and delay time under the action of outdoor view and indoor view are calculated respectively. Finally, the two harmonics are superimposed and corrected to obtain the inner surface temperature and its occurrence time. The first step, calculate outdoor solar air temperature. The average outdoor temperature of 30 degrees Celsius, internal surface solar radiation absorption coefficient of 0.48, and internal surface heat transfer coefficient of 19, average solar radiation intensity of 206, and internal wall long wave radiation temperature of 1.8 degrees Celsius are substituted into the calculation formula of outdoor average solar air temperature, and the outdoor average solar air temperature is 33.4 degrees Celsius. The maximum and average values of solar radiation, the surface solar radiation absorption coefficient 0.48, and the internal surface heat transfer coefficient 19 are substituted into the calculation formula of the equivalent temperature amplitude of solar radiation to obtain the equivalent temperature amplitude of 14.2 degrees Celsius. Outdoor temperature amplitude equals 35 minus 30 equals 5 degrees Celsius. In order to find out the time difference correction coefficient, it is necessary to calculate the amplitude ratio of solar radiation equivalent temperature and outdoor temperature and the time difference of the maximum value. It is noted that the ratio of various amplitudes is calculated by molecules with large values. The ratio of equivalent temperature amplitude to outdoor temperature amplitude is calculated as 14.2 divided by 5, which is 2.8. The maximum solar radiation intensity appears at 16 o'clock, and the maximum outdoor temperature appears at 15 o'clock, with a time difference of 1, according to the ratio of amplitude 2.8 and time difference 1. The correction coefficient beta of time difference is 0.99 by checking table. Then the solar air temperature amplitude is the sum of outdoor temperature amplitude and the solar radiation equivalent temperature amplitude multiplied by beta equal to 19 degrees Celsius. The maximum value of the solar air temperature is equal to the average value of the solar air temperature plus the amplitude, equal to 52.4 degrees Celsius. It can be seen from the calculation results that solar radiation has a greater influence on indoor overheating. The formula for calculating the time when the maximum solar air temperature appears is not introduced, which is equal to 15.75. That is a quarter to 16. Step 2. Calculate the attenuation multiple and delay time of outdoor wave propagating to the inner surface. The thermal conductivity, heat storage coefficient, and thickness are listed in the table according to the hierarchical number, and the thermal resistance and thermal inertial index of each layer are calculated and summarized. The total heat transfer resistance is equal to the sum of the thermal resistance of each layer and the heat transfer resistance of the inner and outer surface. It is noted that the heat transfer resistance of the outer surface is 0.05 in summer. Then the external surface heat storage coefficient of each layer is calculated according to the temperature view from the outside to the inside. The Y2E of the second layer does not need to be calculated because the D value is greater than 1, which is equal to S2, namely 2.76. YEF is equal to Y3E. Then the inner surface heat storage coefficient of each layer is calculated according to the temperature view from inside to outside. The Y2I of the second layer does not need to be calculated because D2 is greater than 1, which is equal to S2, namely 2.76. The Y3I behind the second layer is not required to be calculated because D2 is greater than 1. YIF equals Y1F. Substituting the above calculation results into the attenuation multiple and delay time of outdoor harmonics, the attenuation multiple is 22.89 times, and the delay time is 7.88 hours, namely 7 hours, 52 minutes, and 8 seconds. Step 3. Calculate the inner surface temperature, attenuation multiple, and delay time of indoor wave propagation to the inner surface. Indoor average temperature is equal to outdoor average temperature plus 0.5 is equal to 30.5 degrees Celsius. The calculation formula of the average temperature of the internal surface is not introduced in the previous section, which is equal to the product of the average indoor temperature plus the difference between the average outdoor solar air temperature and the average indoor temperature divided by the heat transfer resistance and the internal surface heat transfer coefficient. That is 30.8 degrees Celsius. The internal surface temperature amplitude caused by outdoor harmonics is equal to the outdoor solar air temperature amplitude 19 divided by the attenuation multiple of 22.89 under the action of outdoor waves, and 0.83 degrees Celsius are obtained. The time of the highest temperature on the inner surface caused by the outdoor harmonics is equal to the appearance time of the highest value of the outdoor solar air temperature plus the delay time of 7.88 hours under the action of the outdoor harmonics, which is equal to 23.63 o'clock. That is 23:37:8. Using the internal surface heat transfer coefficient and the internal surface heat storage coefficient, when the harmonic is from inside to outside, the attenuation multiple under the action of indoor harmonic is 1.49. According to the known conditions, the indoor air temperature amplitude is equal to the outdoor air temperature amplitude minus 1.5, equal to 3.5 degrees Celsius. Then the amplitude of the inner surface temperature caused by indoor harmonics is equal to 3.5 of the indoor air temperature amplitude divided by the attenuation multiple of 1.49 under the action of indoor harmonic, which is equal to 2.35 degrees Celsius. Using the inner surface heat transfer coefficient of 8.7 and the inner surface heat storage coefficient of 4.98, when the harmonic moves from the inside to the outside, the delay time of the indoor harmonic transmission to the inner surface is 1.07 hours. Considering that the maximum value of indoor air temperature appears 1 hour later than that of outdoor air temperature under the known conditions, and the maximum value of outdoor air temperature appears at 15 o'clock, the time of the maximum temperature on the inner surface caused by indoor harmonic is equal to 17.07 o'clock. According to the ratio of the inner surface temperature amplitude caused by indoor harmonic to the inner surface temperature amplitude caused by outdoor harmonic, and the difference between the appearance time of the maximum temperature of the inner surface caused by the outdoor harmonic of 23.63 and the appearance time of the maximum temperature of the inner surface caused by the indoor harmonic of 17.07 was 6.56, and the time difference correction coefficient was found to be 0.71. Then the inner surface temperature amplitude is equal to the sum of AIFE and AIFI multiplied by beta, equal to 2.2 degrees Celsius. Then, considering the superposition of indoor and outdoor harmonic, the maximum value of the inner surface temperature is the average inner surface temperature 30.8 plus the amplitude of the inner surface temperature, which is equal to 33 degrees Celsius. By comparing this value with the maximum outdoor temperature of 35 degrees Celsius, it can be seen that it meets the insulation standard. Finally, substitute the appearance time of the highest temperature on the inner surface caused by the indoor harmonic, the inner surface temperature amplitude caused by the outdoor harmonic, the inner surface temperature amplitude caused by the indoor harmonic, the time difference of the two maximum harmonic values into the calculation formula, and find that the maximum value of the inner surface occurs at 18.78 o'clock, that is 18:47. So far, this example has been solved, from which you can see that the calculation of summer attenuation multiple and delay time can be used to test the heat insulation effect of the enclosure structure and determine whether it meets the heat insulation standard. Also, since the calculation process is very cumbersome, so what can simplify the calculation is the maximum value of the room temperature and its occurrence time the same as the inner surface of the enclosure structure.